Imagine a world without the moon, no tranquil glow in the night sky, no tides rhythmically shaping our coasts, no lunar inspiration fueling human curiosity and exploration for millennia. Now imagine this, Earth's very survival, its stability, its seasons, its life, hinging on an object that might not have been here in the first place. The moon's presence seems inevitable now, but its origin is one of the most astonishing mysteries in science. How did it get here? Was it a cosmic accident, a violent creation, or something else entirely? Today we're diving into the incredible theories behind the moon's formation, each more mind-blowing than the last. Let this sink in. Without the moon, Earth's tilt might wobble chaotically, transforming our planet into an unstable, unpredictable world. Yet, the moon's very existence hinges on events so improbable they almost defy belief. From colossal impacts to interplanetary thefts, the story of how the moon came to be will change the way you see not just our satellite, but Earth itself. It starts with a collision of apocalyptic proportions. Imagine a Mars-sized planet called Theia hurtling through the chaotic early solar system. Now picture it smashing into a young Earth with a force so immense it melts both planets. The impact sends trillions of tons of molten debris into orbit, forming a fiery ring around Earth. Over millions of years, gravity sculpts this chaos into the moon. This theory isn't just science fiction, it's backed by compelling evidence. Lunar rocks brought back by Apollo missions reveal a chemical fingerprint almost identical to Earth's crust, suggesting a shared origin. But here's the twist. Some scientists argue that the moon might be more Earth than Theia, formed almost entirely from material blasted off our planet. If true, the moon isn't just our neighbor. It's a fragment of Earth's violent past, preserved in orbit like a cosmic time capsule. Yet questions remain. Why does the moon's core differ so drastically from Earth's? And why does the moon's orbit behave so uniquely in the solar system? The giant impact hypothesis explains much, but not everything. Could there be another layer to this mystery? What if the moon has been Earth's companion since the beginning? The co-accretion theory suggests that Earth and the moon formed side by side from the same swirling cloud of dust and gas surrounding the sun. It's a poetic idea, evoking images of twin celestial bodies born together in the cosmic cradle. This theory explains why the moon and Earth share similar compositions, but it stumbles when confronted with the moon's size, density, and orbital path. If Earth and the moon were siblings from the start, why do they differ so profoundly in structure? And why does the moon lack a substantial iron core like Earth's? These questions suggest that the moon's origin story is far more dramatic than a peaceful co-creation. Now let's consider an idea that's as bold as it is strange. The fission theory proposes that the moon is literally a piece of Earth. Billions of years ago, Earth spun so rapidly that a chunk of its molten mantle tore away and was flung into space. Over time, this fiery fragment cooled and became the moon we see today. This theory might sound like science fiction, but it has an intriguing basis. The Pacific Ocean basin, with its vast emptiness, was once thought to be the scar left behind by the moon's departure. But here's the catch. For this scenario to work, Earth would have needed to spin at an impossible speed, one that defies our understanding of planetary physics. The fission theory might not explain the whole story, but it raises a fascinating question. If the moon isn't just a piece of Earth's history, but a literal piece of Earth itself, what does that mean for our understanding of the planet's evolution? What if the moon wasn't born near Earth at all? The capture theory suggests that the moon was a wandering celestial body, perhaps a rogue planet or a massive asteroid, that strayed too close to Earth. Our planet's gravity ensnared it, pulling it into orbit where it remains today. This theory paints the moon as an outsider, a cosmic traveler brought into Earth's embrace by chance. It explains the moon's size and orbit but struggles with one glaring issue. If the moon was captured, why does its composition so closely resemble Earth's? Most captured moons, like those of Mars, are chemically distinct from their host planets. Could it be that the moon's journey began elsewhere but was fundamentally transformed upon its arrival in Earth's orbit? In recent years, new ideas have emerged, challenging traditional narratives and opening up fresh possibilities. Some scientists propose that the moon didn't form from one catastrophic event but from a series of smaller impacts. Each collision would have ejected debris into space, gradually building the moon over time. This multi-impact hypothesis could explain some inconsistencies in the giant impact hypothesis, such as the moon's isotopic similarity to Earth. Others suggest that the moon's formation involved interactions with multiple planets in the chaotic early solar system. Simulations reveal scenarios where gravitational forces between planetary neighbors create conditions for moon formation. These ideas remind us that the solar system's early history was far more dynamic and far stranger than we once imagined. But the most exciting part? The story isn't over. New lunar missions like NASA's Artemis program aim to explore regions of the moon that have never been studied. These missions could uncover evidence that rewrites everything we think we know about our closest celestial neighbor. Beyond its origins, the moon plays a critical role in shaping life on Earth. Its gravitational pull stabilizes our planet's tilt, creating consistent seasons that allow life to flourish. Its tidal forces shape ecosystems, influencing everything from coastal habitats to the migration of marine species. And its presence protects Earth from catastrophic wobbling that could render the planet uninhabitable. The moon is more than a companion. It's a cosmic safeguard, a stabilizer that makes life on Earth possible. But its impact isn't just physical, it's cultural, emotional, and symbolic. From ancient myths to modern science, the moon has been a source of inspiration and wonder, a reminder of humanity's place in the universe. The moon's story is one of cosmic violence, mystery, and profound beauty. Whether it was born from Earth's fiery past, captured from the depths of space, or forged in the chaos of multiple collisions, its presence is nothing short of miraculous. It's a reminder that the universe is a place of staggering improbabilities, where even the most unlikely events can shape the course of history. So, what do you think? Is the moon a fragment of Earth, a wandering outsider, or something else entirely? Share your thoughts in the comments, and if this journey into the moon's mysteries has left you as awestruck as it has us, don't forget to like, share, and subscribe. Because the universe is full of stories like this, waiting to be told. Keep looking up. The answers are out there, and they're even more astonishing than we could imagine.